My name is Musa Stephen Honle, as Bashi introduced. I will be entertaining you guys through this session. So today we are going to look at three key components: the Internet Routing Registry, the Resource Public Key Infrastructure, and the PeeringDB. And we are going to discuss how we can use them to secure the routing table. So you can follow us at AFRINIC IP Academy on YouTube. Also, you can find us on Twitter. Yeah, that's it. So starting here, let's do a quick refresher. Type in the chat section what you think when we talk about internet in the routing perspective. What do you think about when we talk about internet? So type in the chat section. Over to you. And as Bashi said in the beginning, we want this session to be very interactive. That's why we are trying to keep you engaged. So how does internet work in a routing perspective? In terms of routing protocol, how packets are routed, things like that. Okay. All right. Oh, you can't hear me? Hello. Can you hear me clean and clear, please? There is Roland. Roland, can you hear me now, please? Okay, good. Thank you, guys. So yeah, in terms of internet, we as engineers, how do we define internet? How does it work? Okay, I will be reading some of the comments in the chat. All right. So Sylvain says it's connected networks. Someone says internet is a network of networks. Yeah. I hear some eBGP, peering, filtering, internet exchange points, etc. Internet uses BGP and forwarding paths as shared between autonomous systems. That's excellent. That's actually what we are expecting to hear from network engineers. So internet is a set of networks that are connected together. And the protocol that manages the backbone of the internet is BGP. And when we talk about the global routing table, we cannot talk about it without mentioning BGP. So BGP. Yeah, so now let's look at, okay, yeah, different routes configured with different interior and exterior gateway routing protocols. Okay, internal routing, external routing, interesting. Yeah, that's quite interesting. So let's move on. Let's move on. So the internet works, the global routing table is governed by BGP. So the BGP controls the backbone of the internet. And as of date, is more than 800,000 routes that are routed globally. And this table grows every single day. Rule number one, when you're configuring BGP on your network, if you are pairing with, let's say, your upstream provider or some other peers in your country at an internet exchange point, rule number one, filter. Always filter. It is very important to filter. Rule number one. Rule number two, filter. Rule number three, filter. So filter, filter, filter. Now, when we talk about filtering, you filter prefixes, you filter AS paths. So which prefixes are you going to filter? Which AS path are you going to filter? So originally, filtering was based on trust. So if I'm ISP A and I have a prefix and I want to pair with IXPB, what I will do is I will ask IXPB, what's your prefix? What's your AS number? Then based on that trust, I'm going to, allow his prefix through my network, and he is going to allow my prefix through his network. So that's how originally BGP was meant to function. So with that model, with the original model of BGP, what is the problem? Is there any problem with that you can think about? Is there any problem you can think about? If there is any problem you can think about, type in the chat section. What problem do you think the original way of operating BGP will create? So what possible security incidents you can think about? Type in the chat. Hello. Do you find any problem? Do you think there is any problem with the current way BGP works? Malicious prefix advertisement, that is from Diren. We have more than 50 participants. Please type what BGP hijack, forged IP addresses, that's spoofed, IP prefix hijacked, okay, lot of work, administration tasks. Okay, so thank you for participating. What we will retain here are, we have 3 major incidents that can occur. The first one is route hijack or BGP hijack. The second one is route leak, and the third one is IP spoofing. So let's look at how that works. So let's assume this is my network. This is the internet actually. So if this is the internet, and let's say I am customer. If I'm customer and I am having prefix 2001 DB8:/32, I will make that prefix available to the internet through my upstream provider, which is ISP. So I will send a BGP advertisement to my ISP. My ISP will push that BGP advertisement to the internet, and it will eventually get to ASX. So if ASX wants to reach me, they know how to reach me because that advertisement was made through my ISP and through the internet. So they will get back to me. They will send their traffic back to me, and back to me. In the current scenario, let's say there is a malicious network out there, which is called attacker. If attacker decides to advertise the same prefix, that's the 2001 DB8/32. If they advertise this prefix to their upstream provider, which is ISPB, and ISPB decides to forward that to the internet, and eventually it gets to ASX, what happens here is when ASX has a traffic to send to my prefix, if attacker has a more specific, let's say it advertises A/36, if it has a more specific or a best AS path, my traffic would end up going to them. So when traffic would be sent, it will go to attacker. A very famous example is what happened in 2008 with the prefix of YouTube that was hijacked by Pakistan Telecom. So they were having some funny videos that the Pakistan government didn't want to see. And then Pakistan government asked the Pakistan Telecom to stop YouTube in the country. what Pakistan Telecom did actually, they went ahead and advertised the prefix of YouTube. But when they advertised that prefix, what happened is the prefix leaked out to the world. And for some hours, everybody thought that YouTube was in Pakistan. And that's how YouTube for hours was down. So that's how prefix hijack happened. Now, apart from prefix hijack, we also talked of prefix leak. So prefix leak is when in a network, I have a multi-home customer. Here, this customer is connected to ISP A, and this other customer is connected to both ISP A and ISP B. So let's say we have, Google advertising, let's say 8.8.8.8. It gets to ISP B, then gets to customer. If customer decides to send that 8.8.8.8 to the second upstream provider, what happens here is upstream will believe that there is a better route to get to 8.8.8 through customer. And then eventually the traffic from this other customer will go through the other customer to the internet. That is what we call route leak. So this is the second incident. This is the second problem that can happen on the internet. And while I'm talking about this, people might say, how frequently this is happening? Route incidents happen every single day on the internet. Right now, if you go to bgpstream.com, you will see that there are route outages out there happening. It happens on a daily basis. It happens on a daily basis. So if you go to bgpstream.com, you will see, actually this graphic that I'm displaying, I took it some few hours ago. So when I took this this screenshot, you can see here we have route leaks. It might be route leaks or route hijacks all over the world. Everywhere we are having outages. Everywhere. And yeah, so the most recent one I am aware of happens this morning in Tanzania. It lasted for more than 30 minutes. There were many roads in Tanzania that were not available because of a route leak. So you can go on BGP Stream and you will see what is happening right now. Okay, so how to mitigate? How do we stop this? How do we prevent this from happening? Or in case it happens, how do we reduce their effects on our networks? So there is the MANAS, which is an initiative from the Internet Society. MANAS stands for Mutually Agreed Norms for Routing Security, whereby we are inviting organizations, network operators, ISPs to come together and apply 4 current actions to secure the routing table. And what are these actions? Those actions are, first, filtering. So each time you want to do BGP with upstream and other peers, make sure you filter. Filter inbound and outbound. We'll never get tired of saying this. Always make sure you filter. Filtering is action number 1. That's action number 1. So MANAS, although it's one fancy way of saying how we should secure the global routing table, is actually a set of best practices. So number 1, filter. Number 2, anti-spoofing. when you configure your network, always make sure that you activate reverse path forwarding. What prefixes are allowed to get in your network? Should a packet come into your network has a source address, your own IP address, your own IP space, you should block that at your border routers. So filtering, anti-spoofing. Number 3, coordination. And number 4, global validation. So today we are going to look at how we use IRR, RPKI, and PeeringDB to do coordination and global validation. So coordination and global validation, the tools we will use, the IRR for Internet Routing Registries, RPKI, Resource Public Key Infrastructure, the PeeringDB, which is a common place where network operators are allowed to come and register themselves, register their resources, their locations, their peering locations, their peering facilities, and everything about them. And also, you can use your website to publish information about how you manage your network. So let's start with the Internet Routing Registry. So what's the Internet Routing Registry? It is defined in the RFC 2622. And it is a public repository where you can store routing policies. So your routing policy is actually how packets go in and out your network. And this is stored on those various repositories using the RPSL language, that is the Route Policy Specification language. And those objects stored there are very, very important, and they are publicly available. So very, very important. They are publicly available for everyone to see, and is the routing policies. So why am I emphasizing on these two parts of my definition? Remember, we said we want to filter, but what are you filtering? How do you know what to filter? How do you know what AS to authorize in your network and what AS not to authorize? How do you know what prefixes are used by whom? You need a common place, a common public place where all of these are stored. And these IRRs are managed by various internet routing, are managed by various regional registries. The IRR. In our region, we have AFRINIC. We have in other regions, RIPE and CC. In Europe, we have ARIN. In North America, we have AFRINIC. In Asia and Pacific, we have LACNIC. So those are the various registries. And these registries have like various databases where all of these routing policies can be stored. For organizations like AFRINIC, RIPE and CC, ARIN, AFRINIC, they can use their WHOIS database to store the IRR object, while LACNIC is using the RADDB. The RADB can also be used by the other organizations as an alternative. So why should we use the route registry? So the route registry comes with a standard format of storing routing policies using RPSL. Remember, we have many thousands of organizations out there connecting to the internet, and each of them have their routing policies. Each of them have their formats of storing their routing, of specifying their routing policies. Now, if we could think of a common way of representing these routing policies, that would be good. So first advantage of using the IRR is the standardization. Second, if we have a common place where all of these routing policies are stored and they are using a specific language, it will now be easy for us to create BGP ACLs. So it is simple for us to create BGP ACLs. And also, because we have that common place where all of these routing policies are specified, I know exactly to whom which resource belongs. And I know which ASN is authorized to route which prefix. Still, it is easy for network troubleshooting because a couple of organizations out there have created tools where we can use to pull out those routing policies and facilitate troubleshooting and also facilitate filtering. So there is like the IRR toolkit, which is a set of tools that you can use to generate your filters, to generate your BGP configurations, and also for troubleshooting when you have issues in your network, troubleshooting or debugging in case of incidents in your network. So that's why we should use the routing registry. Very important. Now, what are the functionalities of a routing registry? The first functionality is for interdomain routing policy specification, because we have a common place where everybody can come and specify their own routing policy. It is also there to tell which prefix is tied to which ASN. And because we have that common place, we have a set of toolkits that we can use to generate either configurations or various prefix lists. Now, what are the IRR objects that we can use? So this is an example of network. This is an example of network where you have my ISP having two customers and a peer, and it also has a transit provider. So in this scenario, what is the routing policy? What should the routing policy of, say, my ISP look like? So with regards to the upstream provider, my ISP should actually send his prefix, the customer's prefixes, but they should not send their peers' prefixes because they are not operating as transit provider to the peer. With regard to the peer, my ISP should send his prefix, the customer's prefixes. Now, with regard to the customers, my ISP should send the peer's prefixes and maybe a default route or the global routing table, depending on the policy, the peering agreement that they have with their customers. In no case should ISP send the prefix of their peers to the internet. In no case. So now, how do we specify this using IRR object? The first IRR object we will talk about is the auth_num. That is how we represent the ASN in the WHOIS database. So ASN 64500 is my IXP. Description, status, it is assigned, org, and so on and so forth. Now, the customers, the first customer was 64501. From customer 64501, I want to accept what they are originating. To customer 6501, I want to announce everything that I have because I am their transit provider. They should pass through me to go to the internet and everywhere else. Same policy applies for customer 2 because these are my customers. I will accept what they are sending to me, and that is tied to their ASN, and then I will send to them everything that I have, any network I know. Now to the peers, to my peers, what am I sending to my peers? To my peers, actually, from them, I will accept everything that they originate and their customers. And to them, I will announce myself and my networks. To transit, to the transit provider, from them, I will accept anything except what I am actually filtering through my filters. So filter in here is a prefix filter, is a prefix list to filter what I have to accept. So let's say my agreement, my peer agreement with my upstream provider, if it's to accept the global routing table, this will actually be the filter list where I block all the merchants, I block everything that is not yet allocated, I block everything that is reserved. That is with regards to IPv6. If it's with regards to IPv4, I will block the private space, I will block everything that's not yet allocated, I will block everything that is reserved. Then exporting to my transit provider, I will announce everything that I originate and my customers. And then this object is a secured object. This attribute they maintain by is how we secure objects in the AFRINIC WHOIS database and also some other WHOIS databases. We just finished talking about the autonome, which is how you represent the ASN in the WHOIS database. The second object, the second IRR object that we'll talk about is the route object, which is how we specify which ASN is allowed to route to originate an IPv4 space, and the route 6 object, which is how we specify which ASN is authorized to originate an IPv6 prefix. So in this case, we can see that this route 6 object is for prefix 2001 DB8/36, and it is authorized to be originated by AS64500. Again, this is a protected object. That's why it is protected by this maintainer, the MNT by. And then the next object is the AS set. So the AS set is how you represent your customer's con. For ISPs, having customers that they have to propagate their prefixes, then need to create an AS set to specify what are the members of their network. And for example, this is an AS set for my ISP according to the diagram we just saw previously. So the members here are AS64501 and AS64502. And this also is a secured object. So only the person or the network having the password to this maintainer can actually create or modify this object. And for some upstream, for some transit provider out there, if you don't have your IRR objects in the WHOIS database, they won't allow your prefix to be propagated on the internet. So that's how we can use the Internet Routing Registry to secure our BGP advertisement, our BGP updates, our BGP global routing table. So there are some other objects, IRR objects, which we will not dwell on here. I talked about the AS set already. There is the route set, there is the RTR set, there is a filter set, there is a peering set. So these are some other objects that can be used by RPSL to specify their routing policy. So we just saw here the various IRR objects that are used by network operators to store their routing policy, to tell which prefix they are entitled to originate and which prefix are from their customers. Now, how do you create these objects? How do you create these objects? First step in the WHOIS database, in the WHOIS, you get the template. You get the template, you fill in the template, you submit the objects. If there are errors, you need to fix them until you are successful. It is a very, so at AFRINIC, the AFRINIC WHOIS has a web interface which you can use. You can also use the text. Okay, so next, this is actually the user interface, the web interface. So you go to create object. You go to create object. If you are creating, you need to specify which object you want to create. Is it a route object? Is it a route 6 object? Then you load. When you load, you will now have the template. And in the template here, you will have to specify the various mandatory fields. So the first mandatory field is the root, which is the prefix you want to route. You can give a description. Then which ASN is authorized. Which ASN is authorized to originate this prefix? What is the maintainer? And this maintainer, you need to later on provide the password. You need to later on provide the password. If not, you won't be able to create this route 6 object. So that is the IRR. I will stop here to take questions related to the IRR. Do we have questions? Bashir, do we have questions?
So I'm looking at YouTube. We have our viewers from YouTube. I have a question from YouTube. Do you know why AFRINIC doesn't list the remarks and members in order, but group them by member and then remark?
Okay, so come again, read the question again. Do you know why
AFRINIC doesn't list the remarks and members in order, but group them by member and then remark? So maybe Patrick, you can clarify that from YouTube. and we can be able to answer.
All right. So on Q&A, do we have any?
Q&A. So in Q&A, I have a question. So this can only be done via the WHOIS and not via my AFRINIC.
Right now, it is done on WHOIS, and the AFRINIC team is developing an interface so that you can do it on my AFRINIC as well.
Another question on the Q&A. This time around, it's in the chat. So ensure that you type your questions in the Q&A so that you can manage it easily. Which password is required when creating the objects?
When creating the objects, the password required is the maintainer password. Is the maintainer password. So yeah, let me go back to. So remember on this interface, you have a maintainer maintained by. This is this object. This is an object, and this object comes with a password. So that's the password that is required here when creating a protected object. People tend to confuse this password with the MyAFRINIC password. This is not the MyAFRINIC password. This is the maintainer password. All protected objects are protected with a maintainer. Okay. Any other question?
Another question from Chris. We are an LIR in Uganda. Is it permitted for us to use our IP addresses in another country to provide service?
If that country is on the region, yes. If that is part of, even if it's out of the region, and if it is part of your company, then yes, you are allowed. Let's say you have servers that are located in a virtual space on the cloud. You can use your IPs as long as you can prove to your upstream provider over there that those IP belongs to you. Then that's okay.
Another question in relation to the object is if ISPA customers have downstream BGP clients, are their ASNs also included in the AS set?
Yes, it should be included in the AS set because it is a chain. It is a chain. So if someone is filtering, if a network is actually applying strict IRR filtering, when they look at the AS part, if they don't see a particular AS in the AS set, then they will not accept that advertisement. So that should be included in the AS set. If not, upstream would filter it.
Thank you. So going back to YouTube, Patrick has clarified the question. So this should be in relation to the creation of the AS set.
Okay.
Yes. So if you add an AS set object, you add remark, member, remark, member, remark, member. So I believe the remarks were used to separate, based on the example that you showed, ways to show from the customers, then from your peers.
Yeah.
So his question was initially, why don't you list the remarks and members in order? And he continues to ask, a query list is as member, 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 and then remark, remark, remark. Okay,
that is surely a bug in the system. Please send us that with a screenshot to training@afrinic.net, and we'll channel it to the right person to debug, to see what is actually the problem. So send it to training@afrinic.net.
So 2 more questions and then we can move on. One question is, what is the meaning of the country attribute in AFRINIC IRR database?
At what level? Which object? Which object? If it's in the organization object, an organization has main quarter in the country. So yeah, it will be the country where the organization is based. If it's a person object, then that person should be in a space, should be residing in a country. So it depends on which object that is referring to. Okay.
One last question, Stefan, before we move on. Does the admin C, tech C have to be an individual, or can it be a group, like an internal organization, alliance, like engineering team or support team?
That is a very, very interesting question. We've noticed that most resource members are tied to their resources. They tie people to their resources. So let's say I have an INET block, INET 6 block of 2001 GB8::/32, and then I have an admin contact and a tech contact. Here, somebody will put something like HMS 5-AFRINIC or Bashi 1-AFRINIC. This is not recommended practice, because the day Stevens leaves this organization and we want to contact your admin C, emails will be sent to the wrong person. So what we recommend is creating groups. What we recommend is you creating groups whereby you create a group, and the group actually is represented by a role. So role will be, say, technical group. So tech group. And then in this tech group, you now have, you add various contacts. You can add Stephen, you add Bashir, you add Willie, you add Brice, and so on and so forth. Then now in the tech C here, instead of putting the nick handle of a person, you now put the nick handle of this group. So that, and then in this group, role, the email of this role will actually be something like, let's say, knock@abc.domain. So if an email is sent to this group, all the members of this group will receive it. So it's actually recommended to tie groups to your resources instead of individuals. Okay. Any other question?
Move on.
All right. So we'll move on. Thank you for those questions. It shows we are participating. Thank you very much. Okay, yeah. Josephat was asking how to reset their maintainer passwords. Willie responded already. Thank you. Okay. So yeah. Now we are going to look at the PeeringDB. So the first place where you want to store your routing information, your routing policy, is the IRR. Very important. That's where you store your routing policy. Now, the PeeringDB is a website actually where you can store information about your networks, about your locations, about your resources, about your peering facilities. That is, any information about your network can be stored, and it is recommended you store it on the PeeringDB, so that organizations out there looking for information about you, they can go on the PeeringDB and they will find you. So to register your information on the PeeringDB, you first need to create an account. And when you create that account as an individual, the PeeringDB team will now try to verify that information tied to a specific AS number with your organization. And when that is verified, now you can now input your information as networks, locations, resources. That's your IPv4, your IPv6, your ASN, your peering facilities, like which internet, where are you peering? Which internet exchange point are you present at? So this is an example. This is an example of information from the PeeringDB. Here we have the organization is AFRINIC, and you can do research. You can research for information here. So the organization here is AFRINIC, and we can see the primary ASN here, which is 37177, and this is the ASN that AFRINIC uses for the DNS support. And then you have the IRR objects here, and this is the route set, which is AS37177. If you query actually this on there, you will see the details of that object. And then you can see various locations where AFRINIC is peering. So AFRINIC is peering at SINGS, DINGS, JINGS, Madagascar, RENEX, and so on and so forth. So the list is very long. So you can put all this information, and at SINGS, what are the peering information? So this is the ASN at SINGS, the IPv4 address, the IPv6 address, the peering speed. So you can have all this information here about AFRINIC. And that's how, when you are peering with AFRINIC, you know that this information is verified by the PeeringDB team. So that is how you use the PeeringDB. The PeeringDB is very simple and straightforward. That is where you put information about your networks, your resources and everything, your peering facilities. Now, we've just talked about the IRR. We also talked about the PeeringDB. But as we can see, with all of this is not really advanced secure, because even with the IRR, information is not updated all the time, and route leaks and route hijacks can still happen. So how do we make this even more secure? Let's look at the RPKI. And RPKI stands for Resource Public Key Infrastructure. It is standardized in the RFC 6480. It is a specialized PKI framework which is used to secure the internet routing infrastructure. And it is a cryptographic method to associate a prefix, be it V4 or V6, to an ASN. So actually, how does it work? How does it work? First of all, the objectives of RPKI is to prove use of resources. So am I, as ASX, authorized to route prefix 2001 DB8 : /32? Am I authorized to route this? How do we know that? Yes, we previously said you can add this information in the IRR. But to make it even more secure, we are now talking about the RPKI. So we will sign this information, the AS and the prefix, in a type of object called ROAS, Route Origin Authorization. So we all know about the resource public key infrastructure where it is used to authenticate and authorize information. But here in the IRR perspective, we are going to use this for authorization. That is, this prefix can't be routed by this AS number. And also, it is used to sign because now we have a certificate, and those certificates are generated by the end users, the ISPs, and the regional registries. So it is now used for secure interdomain routing. So this is an overview of the public key infrastructure. We first have the infrastructure itself with its components, the CA certificates, the entity certificates, and the trust anchor. The trust anchor is the chain of trust between IANA, the IRR, the various ISPs, and the end users. That's the chain of trust. So at each level of this chain of trust, a certificate can be generated to sign the underlying certificates. And it is left to the various regional Internet Registry to manage the root certificates. Another component is the ROA, which is the actual object that is stored in the RPKI infrastructure, which is actually the resource, the IPv4 or the IPv6 block that is signed with a specific certificate, that certificate generated by the end user, and the end user certificate being signed by the authority, either the LIR, that is the local Internet Registry, or the regional Internet Registry. And then we have the repository where all of these objects are available. We have the manifest of the various signed objects, and then we have, like, at any ISPs or at country level, we can now create tools, we can now configure servers to download this manifest and, you know, validate that the route that we are trying to originate or the route that we are trying to accept are actually valid. So I just explained how the various certificates are generated. So IANA, which is at the top, is not doing any CA. So the root CA is at the RIR levels. That is AFRINIC, APNIC, LAPNIC, ARIN, and RIDE. So they manage the root CA. At the ISP levels, or the LIR, there is a client CA, and they will use the CA from the root to sign their CAs. And then at the end site, at the end users, at the end entities, there is also certificate, and this certificate will be used, will be signed by the LIR certificates. And then now at this end, this certificate will be used to sign the prefix and the ASN in an object called the route origin authorization. And then this is going to be stored in the RPKI facility. So this is exactly what I was explaining. So you are a member, you are an AFRINIC member, you have your prefix, you have your ASN, then now you need to generate your certificate. And this certificate needs to be validated by your local Internet Registry and validated by AFRINIC. Then you will now use this certificate to sign your prefix origination. And then this is going to be stored on the resource public key infrastructure. When you've created that and it's stored, how is this ROA used by various networks that are trying to peer with you. So we have, as I presented initially, we have various databases of RPKI. So we have the AFRINIC RPKI, we have AFRINIC RPKI, ARIN, LACNIC, and RIPE NCC. Each of them having their RPKI database. This RPKI database stores all the ROAs that I presented here. It stores all the ROAs for all the members that are already RPKI compliant. And these ROAs, you can configure a validator, an RPKI validator. And this RPKI validator uses the rsync protocol to download the manifests from various registries. And when this manifest is stored here on the validator, if a router, this router wants to peer with this other router. If this router claims to have root 2001 DB8 : /32, when it sends that route update to my router is going to query my RPKI validator to see if this route belongs to ASX. Then, because this validator has already synced with all the databases, it is going to look up for this route. If this route is not available, then my router, depending on my policy, might be rejected. So they are invalid. They are invalid routes. They are valid routes. They are non-existent routes. So what's the uptake? We can do an analogy. A little analogy with the TLS certificate, the X509 certificate, where we have the root issuing a certificate, and then various entities in the tree can use the parent certificate to validate their certificate. The only difference with the ROA system is that we use this not for authentication, we use it for authorization. That's the only difference. So, yeah. So what are the benefits of such a system? We have an established model where we have IANA at the top. We have, let's say, AFRINIC. And here we have our ISP. So there is a chain of trust here between all of these. So if I see a certificate that is coming from AFRINIC, I know I can trust it. Let's say I have an entity here. If I see a certificate that is coming from my ISP, I know I can trust it. And if this certificate that is coming from my entity claims to have ASX with a specific prefix, and then there is the certificate, at this level, that certificate was signed by the ISP certificate, and the ISP certificate was signed by AFRINIC. So this ROA can now sit in the RPKI facilities of AFRINIC, and a third party, somebody running a network, can query this RPKI infrastructure against this ROA. That's how the trust is made. So you don't need to rely only on your peers or your upstream. You can check this route actually in the AFRINIC facility. So the uptake, how are we doing RPKI wise? Globally, this is serious. 17% only. 17% only. And remember, I showed you at the beginning that route leaks, route outages happen every day. And this is because we are not doing well RPKI-wise. So why are we not doing RPKI? And I will even shock you more. Let's look at AFRINIC region. This is AFRINIC region. We are 4% valid ROAS in our region. We have 0.32% invalid. So those invalids are things we can correct. At least these invalids are ROAS that they exist, but they are invalid. So at least we can correct them. But right now, 27,000 networks in our region are not found in the RPKI system. This is a problem which we need to fix. And I expect all of us attending this webinar at the end of this to take advantage of this system. So how do we use the AFRINIC RPKI system? How do we use the AFRINIC RPKI? So this is the workflow. First, you need to submit a BPKI request on the MyAfrinic portal, my.afrinic.net. So you go on the MyAfrinic portal, you connect, and then you submit a BPKI request. When you get that BPKI request, you need to enroll it on your browser. When you now enroll it in your browser, you can add ROAS as long as that BPKI is not expired. Because each BPKI we deliver is valid for 2 years. So when it is invalid, you need to renew it. And renewing is the same process as submitting. So let's look at those steps in detail. So how do you submit a BPKI request? Actually, if you are an admin contact, you just need to send your ID information. You need to send your ID information, your name, your nick handle, and then you send a document, an ID document, say your passport, your national ID card, or your work ID. That is for admin contacts. If you are not an admin contact, you need to submit a request and the admin contact needs to validate that request. So that's the first step. First, get your BPKI. Now, when you get your BPKI, next step is to generate a certificate. You will now generate a certificate using OpenSSL. That's the command, OpenSSL, blah, 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 blah. For Windows users, always make sure you specify the configuration file, the OpenSSL configuration file. Now, once you are, so for Windows users, this is the same command you need to download. You also need to download OpenSSL. For Windows users, download OpenSSL and install it, download and install, then specify the configuration path and then issue this command. Next, you now need to enroll the certificate on your browser. And then when you've enrolled that certificate on your browser, you can now create your ROAS. You will now connect back in the browser where you've entered the certificate. You will now connect and then you'll be able to create your ROAS for your various prefixes. So this is the interface you will have. You will have the possibility to add for IPv4 and IPv6. So this plus will now give you the possibility to select which you will first of all select the prefix you want to add. Say you are having a prefix like 2001 GB8 : /32. You will now select the prefix. Then the prefix will pop up, and then you will have the prefix length, which is /32, and then you will have the max length. The max length, if you are advertising a /32, make sure it's a /32. So I've seen people creating ROAS where they create a /32 to /48. This is actually bad practice. Why is bad practice? Because someone else can use your prefix and advertise a more specific prefix here, and that will be advertised on the internet. So always make sure if you are advertising a /32, create a ROA from /32 to /32. If you are advertising another prefix block, another prefix length, say in this prefix, you are advertising 2001 GB8, let's say : 1000 : /36. You also need to create a ROA for this, which will be 2001 GB8 : 1000 : /36 to /36. So always make sure you do this to make sure that more specific of your prefixes are not hijacked by people, by malintended users out there. So I'll stop here, and if we have questions on RPKI so far, we'll answer them before we can move on.
Thank you, Stephen. A comment from YouTube, just as an FYI, is ensure that you disable any antivirus in case you're trying to use your certificates in your browser. So disable any antivirus and web shields when installing or attempting to use a certificate.
All right, thank you for that feedback. Actually, we've not encountered such problems. So if you've encountered, and that's a hint, thank you very much for sharing that.
Yes. So questions relating to RPKI, I'm just trying to look if some of them we've answered. One of the questions here is where are the certificates if they're not in the BGP protocol?
The certificates are used to sign the object. And those, so you have your prefix, and then you have your ASN. Those two, you will add the certificates to them to create what we will call the ROA. And this ROA is stored on the PKI infrastructure, which is the server that AFRINIC has, which is the server that ARIN has, APNIC, LACNIC. So that's where the certificate is stored. It's stored on the server. Actually, because this certificate, this ROA, has the prefix and the ASN, and it is certified that this prefix, this ASN is allowed to originate this prefix. When I want to peer, say router A wants to peer with router B, what will happen actually? What will happen when router A wants to peer with router B? Here, router A has information from router B. Router A is going to send query to an RPKI validator. This RPKI validator has already queried the AFRINIC server to know all the certificates, the ROA, the certified authorizations that are sitting there. It has also queried ARIN, AFRINIC, LACNIC. So the certificates are sitting there. I hope that's clear.
Thank you. So another question is, so there are some more links linked together. So please explain how the TAL, the Trust Anchor Locator, can enhance the resiliency, security of the global routing system. I believe we will explain this. Maybe you can clarify.
Okay.
Then how the TAL applies to AFRINIC IRR.
Okay, so remember there is a chain of trust already between IANA, AFRINIC, and the service provider. But IANA is not managing any CA, it's not managing certificates. Certificates are managed autonomously by each regional Internet Registry. So, AFRINIC is a CA, is a certificate authority. So they will now validate certificates that are generated by each of the entities in the trust chain. So you have AFRINIC, you have, let's say, ISPX, and then you have an N entity. So AFRINIC here is the certificate authority. AFRINIC is a certificate authority. ARIN and all of them. So everything, all the certificates are managed by the various regional Internet registries. And because all of these regional Internet registries are already tied to IANA, that is where the trust is coming from. And that's how the resilience is managed throughout the global routing table.
Okay, so another question relating to the certificate itself. So this is during the creation of the ROAs. So after installing the browser certificate and logging onto my AFRINIC, we get a browser user identification request, choose a certificate prompt.
Yes.
Then we get the following message: the certificate does not appear to belong to you. What could this be?
It's simple. When you are generating a certificate, you use a nick handle. So if you are not using that nick handle, if the nick handle is mismatched, there is a way the CA, which is AFRINIC in this case, verifies it, and then that error might appear. So always make sure you are using the right nick handle when generating the certificate. At the step of the generation, you actually have to download a PEM file from a link that you will receive through email, and it comes with your specific nick handle and a password. If you mismatch it, if you use a wrong nick handle, then that's where you will get that error.
So for Peter, you can get in touch with us later. We received your email. If there's any more help, we can assist. We have two more questions, actually three, counting the one from YouTube. Let me start with the shortest one. Can I use the RPKI while my upstream provider does not use RPKI?
Yes, you can use it. You can decide to set up RPKI. You can decide that you want to accept only RPKI. The only problem is the routes from your ISP, the route from your ISP directly might have issues, but routes that are originated out of your ISP, yeah, you can, they can be validated through RPKI.
So 2 questions from YouTube. Do you have any test validators we can query?
Pardon?
Any test validators? Any
test validator, go to the website of, I don't have the link of heads. Go to the website of INGS. So INGS actually is a website where you have DINGS, JINGS, and SINGS. Those are the internet exchange points in South Africa. So they have free validators there, which you can use to test. AFRINIC is actually coming up with our validator. We haven't published it, but we'll publish it and we'll send you the link so that you can use for your test.
Another question is, does the ROA need to match a route/route 6 object?
The ROA, no, it doesn't have to match. It doesn't have to match because let's take an example. In the route 6, you might have a prefix, say 2001 GB8::/32. You can create a route object for this prefix. If you created a route object already for this prefix, you don't need to create more specifics of this route object to route more specific routes. Let's say you want to originate the 2001 GB8::/36. Since you already have the route 6 for the /32, you don't need to create the route 6 for the /36. But you need to create a ROA for this /36. So it doesn't have to match. For the route, you need to create the parent. You are not forced to create the more specifics, but for the RPKI, you need the more specifics. So now let's look at RPKI validators. As I presented earlier, we have the various RPKI systems. That is AFRINIC, ARIN, EPINIC, LACNIC, and RIPE. They have their various repository, and then I can configure an RPKI validator, and this RPKI validator will now rely on the RPKI protocol to fit a specific router. So how do I configure this, and how do I set up an RPKI validator, and how do I configure my router to sync using a specific RPKI validator? So this is on Cisco. This is how you configure an RPKI validator. Actually, your OS needs to support this. Okay, so BGP RPKI server on TCP, you need to type the host. The port 3323 is the port that was reserved by IANA for RPKI validations, and then you can refresh any 900 seconds. That is how you configure it on Cisco routers. And if you want to set up an RPKI validator for yourself, you have two flavors out there. You have Routinator, and then you have GoTR. And the setup is very straightforward and very easy. You can use this various documentations to set up an RPKI validator for you. And actually, it's very recommended for big ISPs out there to have RPKI validators. For internet exchange points, it's very important to have RPKI validators which you can make public for your members to use. So yeah, that's the end of the road. If you have questions, then we will gladly answer. Any question? If you have questions, please ask in the Q&A. Okay. All right. Okay, no questions.
On YouTube, any questions?
Yeah, the slides, we are going to share the slides. The video will be shared. Okay. All right, I have a question from Wilson. Wilson says, how stable are these IRR validators? Is there any effect in case router A fails to refresh RUA in time? Yeah, so here we have certificates. So there is extra load that is going to happen to the processing. So if it fails to validate, it's actually not router A that is going to fail to validate. It will take time from the validator to get back to get you back an answer. But these routes, these manifests are very, very light. Actually, right now we have 300 MB. That's the size of the validator cache at this point. So it's not that much. Okay. Question from item Sylvain. I can't see the question. Where is it? Okay, let me check item. Item, can you please type the question? I can't find the question in the chat. In Q&A, I don't see. Okay, yeah, Willie answered to the question already. Willie answered to the question already. Item said, can I use the RPKI while my upstream providers? Yeah. Yeah. Okay, another question from, is it from YouTube? Any idea when if the performance of the AFRINIC WHOIS object creation server will be increased? Okay. So what do you mean by performance? Do you have any issue when you are trying to create objects on the WHOIS? Be more specific. Send us an email and let us see if we can work on that. Yeah. So if Hitam really answered on your question already, saying, remember that RPKI is for the owner of the resource to tell to the internet, my IP resource can be originated by this ASN. So if your upstream provider does not do RPKI, there are two situations. The first situation is you creating your ROA. You can create your ROA if you are having your ASN and your prefix. So you can do that already. Two, the second thing is validating routes using RPKI. So RPKI has two phases. First, you creating your ROAs. Two, you using RPKI to validate. Because you can create your ROAs on the RPKI infrastructure, but you don't validate a route that are coming to you. So that's the two ways. In either way, you can use it indifferently of your ISP being ready. What Cisco IOS supports RPKI validation? Last time I checked, I was unable to use the command I shared with you on Cisco iOS 12. So look from iOS 15. That's something we need to validate. That's something we need to check. But Willie, can you send the link to the Cisco feature validator so that there is a Cisco feature validator, so you can look with your operating system to see if it's okay. Are there any ISPs that accept only signed prefixes? Not to my knowledge, but in Africa, big ISP like CCOM are already doing a lot of RPKI. A follow-up on my previous question, as an ISP, is it okay for me to use my IP block for customer in a neighboring country? Yes, you can use your prefixes for your customers wherever they are, as long as you can prove that they are your customers. Currently, AFRINIC is not even doing auditing, so you can use your prefixes as long as that business is your legitimate business. That's for Chris. What is the best validation period ROA? My AFRINIC allows me to set valid till 2050. This is based on your internal processes. If you are creating a ROA and let's say a team member today managing the network creates a ROA and sets it for 5 years. Later on, you need to always come back and check that this obeys the rules, the internal rules of your organizations. Me, actually, I always recommend 5 years because you always need to come and refresh and take note of your routing policy and make sure that it's up to date. Okay, Willie shared the Cisco feature already. Yeah, right now, a question from, to complement the question from Patrick, was saying that the AFRINIC WHOIS is very slow. Please, I've been using the WHOIS, I've not experienced that. When you have those issues, please try to capture it and send to us, and we'll try to address that. All right, thank you very much. I will ask a last question. from you guys. Please, can you send us a recommendation on next topic that we can cover on RPKI? What would you like us to cover as a webinar topic on RPKI? Answer in the chat. All right, guys, thank you for your time. I hope this was informative. And see you in another session. Thank you. Bye, bye, bye.